So let's continue with the next portion of chapter one here. So we left off at this slide on precision and accuracy. So let's take a look here. What do these terms mean? So accuracy refers to how close you are when you make a measurement to an actual value, to a known value. So, how accurate your measurement is relies on that difference between a known value and what you record. Now, precision, this is after you make repeat measurements. So, say you make three measurements and they are all very close to one another. Your measurements, these series of measurements, will be referred to as precise. This indicates how reproducible your measurements could be. Are you going to get the same values every time you make a measurement? If yes, then you are precise. So we see here some groupings of data where student A, B, and C have done four different trials. So we can see that this known value, the true mass, would be 10.00 grams. And we're going to see some graphs that this data is represented. So we have the average shown at the bottom here. So if you took the sum of these four values divided by 4, so we can see that student C has maybe the most accurate average, the most accurate measurements. Student C may also have the most precise measurements, it looks like. Um, so let's look at how this data is represented here. So again, we know that measurements are said to be precise if they're consistent with one another. So we can see that in C here. All four of these measurements are within a very small threshold of difference of one another. We can see student A is neither accurate nor precise because the measurements are not close to one another. And their average is also the furthest from the accepted value, the 10.00 grams. So student A is inaccurate and imprecise. Student B, they have precise measurements, but for some reason they're all inaccurate. So they're all lower than what we think of as the known value, our 10.00. So there's some kind of systematic error. We might arrive to that conclusion based on this data here. So based on whether or not we have accurate and precise measurements, we can make some assumptions about the experimentation that we're doing. So like with student A here, they're both inaccurate and imprecise. So this could be random error, or the student just is not doing a very good job of adhering to the procedure. Results of student B, they're precise but inaccurate. So this is more of that systematic error. So maybe the device that they're using to measure is faulty in some way, has some kind of issue internally. So it's measuring lower values for the weight. The scale is not calibrated properly. And then student C had little systematic or random error. Both the measurements or the measurements are both accurate and precise for student C. So again, depending on groupings of data, we can make some conclusions about whether something's accurate or precise. Um, Whenever we are working with different units based on what we measure in, sometimes we have to convert to other units. This process is generally called this dimensional analysis. We introduced this our first night of class as well, going from one unit to another. We'll continue with that throughout this course and well into if you have to take general chemistry too. We talked about conversion factors, sometimes being these exact values, these unit equations, a statement of two equivalent values. We looked at how you can use dimensional analysis to start with whatever unit you're given, set up that conversion factor in the middle here of the desired unit on top, the given unit on the bottom. And what happens is if we technically divide by that unit, we're going to cancel that out. And then we're going to be left with our desired unit, which we would in turn multiply by on the top of our conversion factor. So that brings us to our information that is solved. So again, this general problem solving strategy, always identify your given information, identify what unit you would like to end up with at the end, and then you plug in that conversion factor that relates those two units of measure. And would cancel out the unit that you're given and would retain the unit that you would like to end with. We'll continue with a discussion of dimensional analysis whenever we have to either square or cube a factor in a subsequent lecture.